So, lesson 1-8, and today we are going to talk about slope. We go back to the essential question of this chapter: how can you show that two objects are proportional? So, all throughout this chapter, we've been talking about uh, ratios, rate equivalent ratios, and eventually talked about proportional, non proportional relationships. And this is another way of identifying proportional relationships by using slope. Last lesson, I think we discussed about constant rate of change and unit rates, and we will show how all these three are connected to each other. Okay, so the two things that we will be learning in this chapter is that the first thing is I will be able to, I'll be able to learn how to find the slope of a line from a graph. And the second thing that we are going to learn is that I will be able to interpret what the slope of a line represents. So those are the two things that we will learn in this lesson. First one, I will be able to learn how to find the slope of a line from a graph. And the second objective will be I will interpret what the slope of a line represents. Okay, so let's go right away to the key concept of this lesson. And the key concept talks about slope. Okay, and let's define what slope is. When you talk about slope, slope is the rate of change between any 2 points on a line. Okay. Uh, when you talk about rate of change, remember last lesson we did rate of change and we defined what it means to have a rate of change. Okay. When you talk about rate of change, it is the amount of change between two quantities. Okay. So this time we will be applying that same definition when we talk about slope. Okay. So when you talk about slope, okay, slope is actually equal to the change in y over the change in x. Remember last lesson I told you about uh, when we graph linear relationships. Okay, I also discussed on the video change in y over change in x, and that is the rate of change, and that is basically your slope. So when you talk about your rate of change, okay, where the change in y over change in x, that is the same as your slope. So change in y simply means the vertical change, okay? And change in x means the horizontal change, okay? So what does that mean? Let's take a look at this particular graph and let's see what 2 over 1 means. So if this is our linear relationship, this is our linear graph, okay, linear equation for that matter. So you have that straight line right here. And in every straight line, remember that definition, in every straight line, there is only one constant rate of change, okay? And that constant rate of change is nothing more than our slope. So if you look at our change in y, okay, let's take a look at this closely. So look at our change in y. This is our y-axis. So this is our change in y. We're looking at these 2 points, okay? The change in y will be 2 units up. Okay, the change in x will be horizontal change right there. Okay, will be 1 unit to the right. Again, if we use these 2 points, okay, the change in y will be 2 units up, 1, 2, and 1 unit to the right. Okay, so that means the vertical change is 2 and the horizontal change is 1 or 2. So our slope for this uh, linear relationship would be equal to 2. Okay? So another way of looking at your slope, I'll give you an equation which is not in this book, so I suggest you write this down. Slope formula is equal to y2 minus y1 over x2 minus x1. Okay, I will tell you what it means later on, but you need to write this down because this is not in the book. This is the formula that we will be using throughout this lesson as well. Okay, so in a linear relationship, right here, in a linear relationship, the vertical change or change in y value, which is also the same as y2 minus y1, per unit of horizontal change, which is a x value, which is the same as x2 minus x1, is always the same. Meaning to say, the slope of a line will always be the same. Doesn't really matter where you get those 2 points from. The slope of a line will always be, will never change. Let's take a look at this example given in the definition of a slope. If, for example, we take this point right here, and we take this point, and we look at the vertical change over the horizontal change, and if you look at our vertical change, okay, our vertical change would be 1, 2, 3, 4 units. That's 4 units. And our horizontal change would be 1, 2 units. So if I do my vertical change, which is 4, okay, over my horizontal change, which is 2, if I simplify this, this still equals 2 over 1, or simply 2. So you notice that the slope will always be the same for a given line. Okay, so again, when you talk about the change in y over the change in x, this ratio, okay, is called the slope of the function. So this is a function where 2 units are related to each other, x and y, 2 quantities are interrelated. Okay, so again, this is important. The constant rate of change or unit rate is the same as the slope, okay, of the related linear relationship. So what it's saying here is that your constant rate of change, okay, we learned this last lesson, is the same as your unit rate, which is basically your slope. Okay, so those 3 terms are the same. Okay, so let's move on. And the slope tells how steep a line is. So when you talk about the slope, okay, it talks about the steepness of a line. So if this is our line, it talks about how steep it is, how flat or how steep a line can be. So that's what a slope tells us, the steepness of our line. Okay? The vertical change is sometimes called the rise, okay, while the horizontal change is called the run. You can say that slope is also equal to rise over run. So another way of saying your slope, it's rise over run. And if you go back to our example here, this is our rise, okay, which is 4 units, and this is our run, which is 2 units. So this is our rise, and this is our run. So if you make a ratio of rise over 1 on a linear relationship, that tells you, okay, that gives you your slope. And this is this example best exemplifies that, okay? So if you have your linear relationship or your linear graph, okay, such as that one, your rise is this, okay? And if you notice, our rise would be 1, 2, 3, okay? And our run would be 1, 2. So if I do rise over run, okay, this is nothing more than 3 over 2. So the slope of this line is 3 over 2. Okay? Okay. So basically what we're doing there, what I just did is that we counted the number of units that make up the rise of a line. That's what I did. Okay, when I did 1, 2, and 3 in the graph shown above. Okay, and then I counted the number of times it moved to the right, which is the run. Okay, so basically when you uh, count the number of times it goes up, that will be your numerator, and the number of times it goes sideways or horizontal will be your denominator. Okay, so this is your numerator, and this is the same as your rise, and this is your denominator, which is the same as your run. Okay, so we have identified different ways to find your slope. We can use the formula, which is the most common way of doing it. Okay, we can use rise over run, okay, or change in y over change in x. So if we do that, okay, if you notice again, I just mentioned it, the slope of this line will be 3 over 2. Okay, so the slope of the line is 3 over 2. Okay, let's take a look at example 1 and see how that works. So example number 1, the table below shows a relationship between the number of seconds y it takes to hear the thunder after lightning strike and the miles x you are from the lightning. So graph the data and find the slope. Explain what the slope represents. So we have a table where x represents the miles, okay? You are from the lightning, and y represents the number of seconds it takes to hear the thunder, okay, after seeing the lightning strike. So after seeing the lightning strike, okay, basically what this problem is asking us or telling us is that after you see the lightning strike, how many seconds will you be able to hear the thunder after that? Okay, so the table gives us that information. So obviously, when you are 0 miles from the lightning as you see it, okay, it will take 0 seconds for you to hear the thunder. 1 mile takes you 5 seconds to hear the thunder. 2 miles, 10 seconds. 3 miles, 15 seconds. 4 miles, 20 seconds, and 5 miles, 25 seconds. Okay, so these are our ordered pairs. Okay, so we have ordered pairs 0, 0, okay, 1, 5, 2, 10, 3, 15, 4, 20, and 5, 25. These are the ordered pairs that we are going to plot on our graph. And if you notice here, it says that miles is on the x-axis. So you see here, miles on the x-axis and seconds on the y-axis right here. Okay, so if we begin to plot it, this is how it's going to look like. Okay, so 0, 0 is right here. 1, 5 is right here. Okay, 2, 10 is right there. 3, 15 is right there. 4, 20 is right there. And 5, 25 is right there. Okay, so according to what we learned about what slope is, okay, we know that slope, okay, the definition of slope is this change in y over the change in x, okay? Remember what I told you about the formula for slope as well. So slope is also the same as y2 minus y1 over x2 minus x1. Now, how does this formula work? Let's take a look at the 2 points that they used here. So this point is 3 15, and this point right here is 525. Okay, remember, if I use 315 and 525 as my points to find my slope, I can actually label this. Okay, this can be labeled as your x1 because that's your first x coordinate, and this is your y1, which is your first y coordinate, and this is your x2, it's your second x coordinate, and y2, which is your second y coordinate. Okay, if we are going to use those values and substitute those values to this formula, what's going to happen is what you're going to get y2 right here, which is 25. Okay, and I am going to subtract y1 right here, which is 15. And then I'm going to get x2, which is 5 right there. Okay, and I'm going to subtract x1, which is 3. Okay, so that's how we use it, and therefore this becomes 10 over 2, or the simplest form is going to be 5 over 1, or just 5. So the slope of this line is 5, and let's look what the book did. It's exactly what we did, okay? But in our case, okay, hold on. In our case, oops, it disappeared. It's the same thing. This is our y2 minus y1 right here over x2 minus x1, okay? And that's what we got there. The slope is 5 over 1, or simply 5, okay? Now, what does that mean? What does this slope 5 over 1 mean? It simply means that for every 5 seconds between a lightning flash, so when you see a lightning flash, okay, and the sound of thunder, there is 1 mile between you and the lightning strike, okay? So when you see lightning strike and you count 1 second, you count 5 seconds after that, okay, it basically means that that lightning strike is 1 mile away from you. Okay? So do the guided problem and let's see if you understand example number 1. Let's take a look at example number 2. Okay? In example number 2, Ronaldo opened a savings account each week. Okay? He deposits $300. Draw a graph of the account balance versus time. Find the numerical value of the slope and interpret in words. So there are 3 things that we need to do. First, we need to draw a graph of the account balance versus time. Okay, and we need to find the numerical value of the slope. And the last part, we need to interpret it in words. So before we can even graph this, okay, first thing we need to do is we need to create a table. Okay, so that's the best way to graph. Okay, our linear relationship is by creating a table. So in this case, we need to identify our x-axis and our y-axis. So what did I tell you about time? So when we talk about time, okay, time will always be, okay, your x-coordinate. And which is account balance versus time, your account balance is going to be your y-coordinate. So our y-axis will be account balance, and our x-axis will represent our time. Okay, so first let's create our table. So this is our time, and this is our account balance. Okay, account balance amount. Let's do amount because it represents money. Okay, so let's find out how we can complete this table. Now, if you look at our table, it says there Ronaldo opened a savings account. Each week he deposits $300. So for the first week, okay, so obviously for 0 weeks, okay, we'll make time weeks because it says weeks, okay. So for 0 weeks, obviously there will be no money deposited. So the amount will be zero, okay. For the first week, according to the problem, each week he deposits $300. So the first week, Ronaldo has $300. Okay. For the second week, okay, Ronaldo deposit the amount of money that Ronaldo will have since he deposits $300 every week. This becomes $600. For the third week, okay, Ronaldo now has $900. For the fourth week, okay, Ronaldo has $1,200. For the fifth week, Ronaldo has $1,500. Okay, now these are our ordered pairs. 1 300, okay, 2 600, 3 900, 4 1200, and 5 1500. So now we are going to create our graph and we are going to plot those points. And this is the graph that we are going to create. So again, for 0 weeks, okay, the amount is zero. For the first week, it's going to be 300 right here, okay. For the second week, it's going to be 600. For the fourth week, it's going to be 1200. Okay, third week is 900. Fourth week is 1200. Fifth week is 1500. Right there. Okay, so we connect those points. It creates a straight line. Okay, so again, if you notice, as it creates a straight line, we can now actually find the slope. Now, what did we talk about slope? Okay, what are the different names of slope? So remember, slope is the same as constant rate of change. And it's also the same as your unit rate. When you say unit rate, okay, sorry, when you say unit rate, remember that the denominator is equal to 1. And when we talk about slope, remember slope is change in y over change in x. So if our denominator is equal to 1, this will be our change in x. Okay, so that means all we need to do is we need to find, okay, in the graph where x is equal to 1. So in our graph where x is equal to 1, this is where x is equal to 1. So what we can do now is find the value where x is equal to 1 and go to the left to find out that value. And that value, as we know it, will be 300. Okay, so this one right here is actually our unit rate, and it is also the same as our slope. We don't even have to use the formula to find slope. We can if we want to, but this is the easier way of finding our slope. So the slope of the line is the rate at which account balance rises, or $300, per week. Now, let's say you don't want to use the unit rate to find the slope. So that means if you want to use the formula, you can. Okay, so the formula now, if I'm going to use the formula, okay, I'm going to write it right here. So slope is equal to y2 minus y1 over x2 minus x1. I'm going to pick 2 points from my graph. Let's say I pick this point, and let's say I pick that point. So this point right here is actually 3 and 900. And this point right here is 5 and 1500. Okay, so I'm going to use 3 and 900 and 5 and 1500. Okay, so this is my first x coordinate, and this is my first y coordinate. This is my second x coordinate, and this is my second y coordinate. I use the formula for slope, so this becomes now 1500 minus 900 is equal to 5 minus 3. And if we do that, this becomes 600 over 2, or that's the same as 300 over 1. Okay, so 300 over 1 means $300 over 1 week, and we have the same answer as what we got in the example. So you can actually use several methods to find the slope, but if you understand the meaning of what the slope is, then you can readily find the slope by just looking at the unit rate of your graph. Okay, and that's the end of our lesson. Thank you for watching.